So in the previous section, we have seen some introduction to subnetting, where subnetting is a method of dividing one single network into multiple small networks. It majorly minimizes the wastage of the IP addresses. And there are two different methods of doing subnetting. We can either do using FLSM, where we actually divide the network into equal sizes. Okay, that's what we call as FLSM. Or we can divide based on the VLSM, where we can divide the network, may be equal, may not be equal. Okay, so more on calculations we'll see more in detail in FLSM and VLSM, and these are the formulas which we use for calculations. And what exactly we do in the subnetting is we convert zeros into ones. Okay, and we have seen some brief overview on that in our previous section. So probably in this section we are going to directly jump into our calculations. So in this example, in this video, I'm going to show you one of the first example. So first we'll start with the C class example. So using C class, requirement is, let's say 50 host addresses. So I'm going to do FLSM. So mostly in the first 2-3 examples or 2-3 sessions, we are going to do only FLSM because FLSM is the foundation. So first we'll start with FLSM and then we'll go ahead with VLSM calculations also. So the question here is, if you just take an example of any C class network, by default it supports 0 to 255 addresses. That's the default size of the network of any C class. Now I want to divide this network into multiple small sizes so that each and every small size network should get minimum of 50 host addresses. So that's my requirement. Okay, so let us go ahead and start with the calculation first. So if you just go back with the example here, what is the formula which we use if you are calculating based on the host? It has to be 2 to the power of h greater than a minus 2 greater than equal to requirement. So this formula will help us in finding out how many bits we need to convert. So the formula here is 2 to the power of h minus 2 greater than equal to requirement. So here the requirement is 50. So I need to consider the 2 power table. So the 2 power table which satisfies my condition. So if I go with, let me take down the 2 power table here. So this is my 2 power table here. So I'm going to take this 2 power table here. Okay, so which value satisfies my condition here? So my requirement is 50. So if I take 2 power of 5, 2 to the power of 5, it will be 32. So but it doesn't satisfy my condition. My requirement has to be 50. So I'm going to take 2 to the power of 6, 64. So which means even though your requirement is 50, but exact 50 it's not possible. The possible size is 64. Okay, so if you want to divide any network, we get only these possible sizes. So either we can get the 2 to the power of 2 4 size, or 8, 16, 32, 64, 128. If my requirement is 100 host, so I cannot divide a network with exact 100. So the nearest possible size will be 128. If my requirement is 200, the nearest possible size will be 256. So these are the only possible sizes we can divide based on the requirement. So I'm going to take 2 to the power of 6, so which is going to satisfy my condition, 2 to the power of 6, and we are doing minus 2 here. And this minus 2 is for network ID and the broadcast ID, because we cannot use the first and the last addresses. So 2 to the power of 6 satisfies my condition, so it will be 64, and minus 2 we cannot use for network ID and the broadcast ID. So 62 will be your valid host addresses. So which means even though my requirement is 50 here, but I get a size of 64. In that 64, I cannot use the 2 addresses because the first and the last address will be your network and the broadcast address. And maximum in future, if I want to add some devices, if I have to extend, I can extend up to 62 devices. So this is the first step we need to calculate. This is the first step here. Now once we calculate this, now the second thing we need to figure out how many host bits we require here. So here we need to figure out required host bits. So whatever the power value we get here, this power value, now this will be your required host bits, 6. So which means in case of C class, which class we are using here? We are using C class. In C class by default there are 3 network portions and 1 host portion. So if you write them in decimal values, it will be 1, 2, 3, 4, 5, 6, 7, 8, right? Network always represent with ones, and 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. So this is actually the binary format of the subnet mask or the network portions. There are 3 network portions here and 1 host portion here. So which means there are 8 host bits. So out of 8 host bits, I just need only 6, because according to my requirement, if I use 6 bits as a host, that will be sufficient. So which means the remaining 2 bits, we are going to convert them into network. Okay, so or we can do like this. We can write like converted network bits is equal to n bits is equal to, so we can write as total host bits. So we need to subtract the required host bits. So total there are 8 host bits as per my C class example, and I just need only 6 here. Based on the 2 to the power of h minus 2 which I have calculated, I need only 6. So the remaining 2 bits gets converted here. So total becomes how many? Total network bits becomes, it will become by default there are 8 plus 8, so which means by default there are 24 network bits. Okay, and then 2 gets converted, so it becomes how much? 26 network bits. So total becomes 26 network bits here. So which means as per my example here, by default C class supports 24 network and 8 host bits, but after doing subnetting it has been changed to 26 and 6 now. So which means if you just go back with an example which I discussed here, so if I use 8 host bits, 2 to the power of 8 how much? It will be 256 is the size of the network, which is the default size. Now once I reduce the bits to 6, it will become 64 will be the size of the network. So in order to reduce the size of the network, we just need to reduce the number of host bits. So, and how many bits do we need to reduce, or how many bits we need to convert, we can say that will be decided based on this formula. So we use this formula 2 to the power of h minus 2 greater than equal to requirement. This formula is going to help us in figuring out how many bits we need to convert. Now once we calculate this, once we figure out how many host bits we require, and then once we figure out how many network bits and host bits, we need to find what is the subnet mask. Now this is your subnet mask, whatever you can see, this is your subnet mask, but it is in binary format. But we write the subnet mask in which format? We write in decimal format, right? So the subnet mask will be, if you add 8 bits, it will be 255, and if you add 8 bits, it will be 255 here, and 8 bits it will be 255, and then if you add 2 bits, that is 128 plus 64 here, it will become 192. So the subnet mask will be 255, 255, 255, 192. Now the subnet mask changes because the size of the network changes. Okay, so this is your subnet mask. So let me write down the subnet mask here. It will be 255. It will be 255 dot 255 dot 255 dot 192 is the subnet mask. This is your subnet mask. Okay, so now the tally of 24.8 has been changed to how much? 26 and 6, right? So this is the default. Now it changed to 26 and 6. Now the last thing we need to do is we need to write the range of the addresses. The range always written based on 2 to the power of h value. Right now 2 to the power of h value is 64 is the size of the network. Okay, so if I'm writing any C class example, so let's say the C class example 192.168.1 dot 192.168.1 dot 192.168.1 dot, let's say any C class it can be, so it not compulsory that it has to be this. Any C class, the same way we do calculation, so it's going to be the same calculation for any C class. Okay, So now writing the range always written based on 2 to the power of h value as I discussed. So right now the default size of the C class network is how much? So it starts on 0 and ends on 255. So that is the default size of the network. Okay, so now this network is further divided into multiple small networks. I think I'll get 4 networks because 64 into 4 is 256. So now this is further divided into 4 parts, and now the range will be group of 64 addresses will be one network. So which means if I write 0 to 63, 0 to 63 is one network because group of 64 addresses, and 64 to 127 will be another network, and 128 to 191 will be another network, and 192 to 255 will be another network. So just we need to write group of 64 addresses as a part of one network. So either we can write like this, or I generally prefer another way. So I generally write like this: 0 plus 64 will be the next network, plus 64 will be the next network, plus 64 will be the next network. Okay, and my range, you can see the next network starts on 64, which means my network ends on 63, and then my network ends on 127, and then my network ends on 191 because the next network starts on 192 and it ends on 255. So the same thing, this is rough, so I'm going to write it in fair. So the range will be 0 to 63 is one network, or we can write like this: 0 to 0, this is 0, this is 63, so this is 0, and then 64 next network, and then 128 plus 64 plus 64, and it ends on 0 to 63, and then 127, and this will be 191, and then 255. Now as per our calculations subnetting, now this is one network. Okay, this is the first network, and then this is my second network, this is the second network, this line, and this is my third network, and then this is my fourth network. Okay, so these are my first, second and third, 4 networks, and in these networks again this top, this is the first address, this will be my network address or the network ID, and this last address will be the broadcast ID. Now how they are network ID, how they are broadcast ID, I'm going to explain you more in detail after some examples. Okay, so right now in the first network 192.168.1.0 is a network ID and 63 is the broadcast address, and then in the second network 64 is a network ID and 127 is a broadcast address, and then in the third network 128 is a network ID and the 191 is a broadcast ID. So similar way in the fourth network. So everything, whatever you see on the left side, these are the network IDs for each and every network, and whatever you see on the right side, these are the broadcast addresses of each and every network. Now this is how we write the range, and how they are different networks I'm going to explain you after next example. I'll be discussing one more example and I'll explain you on that. Okay, so let me just quickly revise the calculation process. So the first step, we need to calculate, we need to figure out how many, what is my requirement, and then we need to see the 2 power value whichever satisfies our condition. So according to the 2 power table, 64 is the possible size, but I can only use I cannot use the first and the last addresses because of the network ID and the broadcast address. So the valid host addresses will be 62. So from that I get this 6, required host bits is 6, and I'm going to use only 6 host bits, and the remaining 2 I'm going to convert them into network. Okay, so based on that it will be 8 plus 8 plus 8 plus 2. So this will, I'll get this subnet mask. If I convert this binary into decimal, and then total will be the tally of 24/8 will change to 26 and 6. And then finally writing the range. The range is always written based on 2 to the power of h value. Right now the network size is 0 to 63 is one network, 64 to 127 is one network, because these are the group of 64 addresses. Okay, so group of 64 addresses will be one network, so 64 into 4 networks, it will be 256. Okay, so that's how we do calculation. Now this is a very basic subnetting, the first example of subnetting. So like that we can do some more examples by taking different examples in our next session.